Hey everyone, Lior is here, continuing the conversation on Azure IoT Operations. Today I have Simona to talk to me about OPC UA. Stay tuned. Hey everyone, Lior is here. We're continuing Jumpstart Lightning and the video series for Azure IoT Operations. Today I have my friend with me, Simona. Simona, how are you doing?
I'm very well, Lior. How about you?
I'm good. I know that we've been waiting a long time to record this episode. We were both pretty busy. Simona, before we are, just starting to nerd out on all the things, who you are, what is it that you do?
So I'm a senior program manager here at Microsoft, and I'm actually passionate and driving all the industrial connectivity as part of our Azure IoT operation.
Simona, you and I, we just came back last week from the MVP Summit here on campus. You are based in Europe and you join remotely, but I gotta share with you here that specifically on OPC UA and the conversation that we had with the MVPs, I really I was surprised about how passionate people really are about this stuff. As someone that, sure, I have some experience in all of that, but I never thought that like a network protocol can be so, people can be so emotional about that. And I actually like it. So what do you think about that?
We like it as well, and I think the emotion comes from the problem that we are trying to solve, and the spec that OPC UA is trying to cover. One of the things I will say, Lior, is in the OPC UA we don't like it when you refer to us as a protocol, and we are going to show it to you why we are more than just a protocol.
I'm starting with the left foot here with you, Simona. Yeah. So I mean, look. That's kind of an oversimplified way, I know, to talk about OPC UA, and you're going to school me today, which I really like, and specifically about how we're, what are the things that we're doing with OPC UA. So with that, Simona, let's just, dive right in. I know that, first of all, that you want to talk to me about what OPC UA really is, right?
Mm-hmm. So the talk today will actually have two parts. So I want to still take it easy and introduce the OPC UA topic as such. So what is an OPC UA server? What is an OPC UA client? And a little bit the terminology, because we are special. We have our own terminology when we discuss, OPC UA, in order to make sure that everyone can follow our second part, which is more the advanced part, where we talk about the OPC UA broker and the way the broker helps IoT operations and our customers. Are you ready, Lior?
I'll try. I'll do my best.
Okay, so let me first say OPC UA is here for already 20 years, right? So Microsoft has been part of the OPC UA from the moment it was initially started as an initiative. What OPC UA tries to create is the bridge between the automation that it's already advanced and relatively amazing. I mean, think about all the factories around the world that are producing goods in milliseconds and so on, and the IT that enables a secure standard. So we are trying to bridge those two worlds that have for many years grow in amazing with amazing technology, but grow separately, and we are trying to bring them together. The OPC UA as a standard is managed by the OPC Foundation, which tries to embrace the openness of the standard and try to drive it going forward as an open initiative. So what it means is it creates a standard data model. We need those data models. We are still at the beginning of our journey, but basically we want to make sure that every industrial machine, regardless of how complex or how simple it is, has a model that we can then understand the data that the machine is reflecting. At the moment, there are around 60 open source companion specs as part of the data models, and we know organizations around the globe have developed their own proprietary data models. However, the journey is ahead of us, and at Microsoft, we are really supporting any organizations or any initiative that try to bring the clarity around those data models and try to embrace them as part of the OPC UA. Yeah. The second part, and one of the things that comes really close to our values, is the OPC UA allows us to enforce security profile. So we all know one of the main concerns of many factories that are trying to go through the digitalization process is that we are moving from, air gap, or basically no network, no internet connection into my factory, into one that includes an internet connection. And as part of that, we need to take care of the security. OPC UA gives us options there, options that go from the way we handle authorizations, authentications, from the way we set up the security profile, in a way that we can still manipulate the data, right? We if everything becomes too close, it's back to today where we don't have the data out of many factories and we cannot centralize the operation of many entities out there.
Yeah.
And the third part, and this is where the protocol, especially the word protocol, is the one creating some confusion over here, because in the area of OPC UA, we claim that we are protocol independent. And for that, we say from the TCP IP to the UDP to others, and especially embracing the new type of communication protocols like MQTT, we support all of them. So that means OPC UA tries to be there where the customer is and tries to evolve as the market evolves. As mentioned at Microsoft, we are really driving the initiatives around enablement of the OPC UA over MQTT, which is one of the things we believe it's good for the industry and it's good for the openness of this field.
And Simona, one thing that I wanted to mention here, and you touched on the element of security, right? And as we're working to, as factories, or not just factories, like industries in general, are just moving to a more connected world, right? I think that the one thing to bear in mind here is that, these physical devices that we're talking about, right? The boilers, the PLCs, all these devices that we refer to as assets, and we'll talk about it a bit later, right? These are the problem here, or the challenge, right? That they're physically accessible, at the end of the day. When you're walking in a factory floor and you have like either a robot arm, or, if you walk into, maybe a company that is all about, has got boilers or something like that, right? These are physically accessible devices, right? That someone can be like, being a man in the middle situation is not like science fiction in this type of stuff, right?
No. And there are lots of examples out there where, with a USB stick that you run around the device and you can still. So that's why security is really important. And we need to look at it holistically, not just from one panel there.
All right.
Okay, so going forward, I wanted to show you if you look from the IT perspective or from the digital transformation perspective, a couple of the things that you need in order to get started with OPC UA. As a disclaimer, I'm not setting up an OPC UA server. We have partners and lots of industry experts that are doing that. I just try to show you what are the couple of elements that you will see later on as we are talking about IoT operations and we are requiring there. So let me switch here. I have a very good simulator that allows me to highlight a couple of things and the terminology as well. When we talk about an OPC UA server, we usually talk about the server endpoint URL that includes a structure like this. So you'll have an OPC, you'll have the TCP, and then you have the port and a couple of elements that describe this. When you look at the security policy, I have here a simulator. I'm in a very lucky situation to say, accept sessions from any client and then be able to connect to anything. This is not a reality on many OPC UA servers out there. So that's what I usually say. In order to have a smooth transitions in using OPC UA, get into a coffee with your OT expert. He will be able to tell you about the network topology and the settings and the policy and the certificates that the OPC UA server are requiring. We are going to enable more discovery, but that helps a lot. That sometimes saves a couple of good hours of work. The security mode, so again, this is a typical OPC UA terminology. The security mode varies from none up to sign and encrypt and TLS. And then the user, so we have two things. We have security mode around the connections, and then we have the users that are able to connect to this or to trigger these connections. This can go from the typical username, password, up to a user certificate that can be added here. Again, it is our recommendation. We see most of the cases where customers come to us and say, I cannot see my OPC UA data, I cannot see the data streamed, or I don't see all the data. In 90% of the cases, it handles to a connection that is not, or that was rejected by the server, right? And then you don't see your data or the data that you like to be able to manipulate.
Yeah.
Okay, and if we look at an OPC UA client, I'm going to just highlight again a couple of the terminology and the meaning of this terminology. So when you look from the client usually is going to be the one describing what's happening. So I'm going to discuss about the session. Why session? Because I have this client-server communication, and between the two of them, I need to have the idea of a session. The session has three main things: has an object, has types, and has the views. So if I scroll down into the object, this is where I find again my server and a couple of things for the server. The server can be technically identified with the node ID. The node ID has this structure that you can see on the screen with I equals something, right? There are multiple attributes, and depending on the project and what you want to reach, all those attributes can be really useful for your setup. But just taking a simple example, I just want to connect to the OPC UA server and extract the clients that are behind them and the data that those clients are generating. Right? So I'm going to look at the node IDs, and from there I'm going to establish the connection to those node IDs. This is what I highlighted, that in the OPC UA server, I can see as well the available certificates and the certificates that the server accepted. So usually I need a certificate from the broker or from the connector. I need the certificate into the server. Without this, the connection will not be established. Basically, my OPC UA server will say, I don't know you, I don't trust you, I'm not going to share my data with you. Therefore, we really recommend to look at rejected certificates to see if the ones that you provided actually has been rejected by the server, and check as well if you have a particular certificate. Check with the provider of the OPC UA server how the certificate can be enabled, or which are the ways that the vendor recommends to enable your connection into their solution. The other thing that it's controversial, but I wanted to highlight, if you are looking into the latest technology that navigates around the unified namespace, so basically bringing data for multiple systems, multiple solutions into one unified namespace. OPC already has for many years the idea of the namespace, and there is bringing already the OPC UA server. It's already consolidating particular data from multiple systems. So it could be that many OT or many factories around the globe already have part of the work done for the UNS, and data just needs to be extracted for the OPC UA namespace in order to fulfill the needs of the business. It is right now on the market controversial if UNS is not already available in OPC UA. I think we don't want to go into that controversy. We just want to highlight that there is already this structure, and this structure can be a good base for setting up a proper UNS and enriching the data that it's available.
And I think that, Simona, as you're switching here to the schema and all of that, I think that the certificate portion here is very important. I mean, you talked about the notion of, how OPC UA is also about standardizing security protocols, right? You showed that, also in the simulator with the encryption methods that are supported, and also the authentication, right, of the username and password. But you also mentioned, which, that's the reaction that I had, like you mentioned the, either expired or drop certificate. I forgot the term that you used there, right? And I think that this is where really the money is, right? Having a certificate to sign a connection or a session, like you mentioned, from a device that, like we said, is physically accessible a lot of the time, right? To be able to establish that connection using a certificate, that's a key thing. Like, it's definitely something to, to keep in mind here for our viewers, that this is not something that we're saying, hey, yeah, sure, just have a certificate and you're thinking about cookies. Like, we're thinking about physically accessible device that can be sitting in a factory floor, So that's a very important piece.
Yeah. It is, Lior, and that's why I said that in the OPC UA, there are enriched policies for security, as well as an enriched tool chain that the OT expert I think many of them are already using it. So, we should not just take one of the things that we see is that many are just looking at the simulator where they see, like you have seen none and none. That's not what you will typically find on a factory there. Right? There will be policies and enforced via the OPC UA. And we think this is the way to go. And this is that's why we are bringing, and later on I will explain, we are bringing in tools so that this trust can be established as well on IoT operation.
Interesting.
Yeah, and so one other thing that I wanted to mention, we are still at the beginning of our journey, but OPC UA provides the XML schema. The schema is there to help all of us understand the clients that the OPC UA server has, and later on be able to establish correlations between the telemetries that those clients are publishing and the interpretation of those. I'm sure we have around our viewers a couple like me that said, well, industrial data, what can be so bad? I will be able to find temperatures and vibrations have a certain formula and so on, and give me the raw data, I will figure it out. That's not the case. Many sensors out there are not giving you the real readable values. They're giving you some hard-coded values. So, for example, instead of getting the temperature, you might get values like 1 or 2 or 3. That means it was an increase by whatever the configuration was. Could be one grad, or could be just a couple of differences there that depending on what the machine is. You can imagine there is a difference between, just a roller and maybe a burner in the setup, and the way the temperature is being set up. So just looking at the raw industrial data, especially as a human, it's usually impossible to gain good insight. So that's why we need the schema, and that's why I wanted to show that the OPC UA schema is relatively flexible. It's true, it requires configurations. That means we need to first build the schema so that then we can use it. But the schema can, has components, or can be built with components, with elements. It can be created in a serial or in a parallel set of setups. So it's flexible, and I will say it can be mapped to the majority of the schemas that a customer will have in the real factory.
Yeah.
So OPC schema, it's a very important topic for us. We will advocate for the broader reach of this functionality, as well as more openness of schemas and interoperability of those components as part of the OPC UA.
Yeah.
Okay, so now we move to the second part where I want to present what we do with OPC UA as part of IoT operation. So we develop an OPC UA broker with the ultimate goal of really enriching and simplifying the experience that many OT experts and developers have when trying to connect to their existing equipment in the factory. We wanted to have a simplified plug-and-play solution. That means I don't want to deal with the complexity of going through all my networks. I really want to understand what is important for me, what type of configuration I need, and I want to make sure that I can apply those configurations in a repeatable way for majority of the factories that I have out there. But the other part where we spend a lot, and we will continue to spend a lot of the energy, is on the scalability and high availability of our solution. So we have been providing solutions, open source solutions based on OPC UA for already 8 years. And one of the problems is that when we reach a certain amount of production data, we need a scalable infrastructure. So that was one of the areas that triggered the next generation of what we have today as an open source project called OPC UA Publisher, and the upgrade to this into the OPC UA Broker. We will be leveraging Kubernetes for this. Reason for that is one of the main pain points, especially when you talk about 100,000 of tags and the publishing interval of seconds to milliseconds, is I really need the infrastructure to enable me to scale up and then scale down when I don't need it. And for us, Kubernetes is the answer there. So the platform that we build really relies on fundamental principles that of the infrastructures enabled in order to scale up as the business is required, and scale down when this is no longer needed. We will continue to do the things that you need from the OPC UA, which is publishing telemetries, implementing control loops in a secured way, and dealing with events. We get more and more feedback from customers that while we enable events, and we are now enabling events as part of the OPC UA, we need to work as well with the event generators, so basically with the machine builders out there, so that they properly flag their events. But we are here to embrace on that journey, right? So it's not just showing you the available events, but working with you and your customers and your suppliers as well to make sure that we really have a way to differentiate between normal telemetry. That means the machines, the sensors are all green, are all reporting good, versus there is something that happened and this needs to be triggered and needs to be published as an event, and later on potentially as an alarm with acknowledgement, right? So something really happened, the technician needs to go and have a look at the device. Those are flows that OPC UA enable. We need the data to be properly structured so that we can then use it and manipulate it. We are targeting as well use cases that go into the area of zero data loss. We really want to get closer to the production lines, as close as possible, and we know that some customers and some use cases will require zero data loss. That means the system needs to be available. We assume failure, so we don't go with the we wish the weather will be nice. We wish the machine will not fail. We assume machines will fail. We assume network will fail. And for that, we bring in mechanics where we can go and trigger again the extraction of data, or we can ping again the PLC to see if they're in the cache or somewhere we can still extract to understand what happened, why did we lost data for a couple of seconds, and we have flows built in that provide functionalities into this direction. We started the journey. I will say I don't want to overpromise here. We started the journey. There is still work ahead of us, but I just wanted to say we are really going towards this zero data loss, which brings a lot of infrastructure as well that we need to have available for us. And this brings me back to Kubernetes, right? When I will basically need to spin on another resource to go and grab the data that I lost five seconds ago and ingest it at the right time, so that for a data scientist, the data stream continues to be continuously, and they don't see that there was a friction then between different systems. That is our vision for how to implement zero data loss.
Yeah.
And then we have seamless integration. What this means is we are not going to ask a user to go and install Acre here, deal with the device registry there, see how you configure Arc over there. So we are working in a seamless integrations under the umbrella of IoT operations to make sure that the user has a good experience.
And Simona, I wanna intersect here for a second, just kind of talk to you about the data portion here. Just again, a reaction. This is for people that are potentially new to this, or just getting started with this entire thing. I mean, at the end of the day, the industrial IoT, or people may refer to as Industry 4.0, right? It's really about the data. That's really kind of the point with this entire thing. So as we're thinking about, when we're saying data, it's not. There is a thing here that people needs to understand, which is, look, this data is about analyzing how the business operate, the efficiency of a factory floor, machinery, all this stuff. So making sure that the infrastructure is reliable, right? That's the fundamental building block. And I think that, before this, I would say that with Industry 3.0 and all of that, I think that was the thing that a lot of the jump between these evolution period of times, right? That's where it comes to life. Like this notion of taking care of the fundamental building blocks of the infrastructure that's supposed to support the data pipelines, right? So when you're saying zero data loss, again, without over-promising, the notion of zero data loss is important. That mindset is just enough to make a change in how we're thinking about stuff, So
I fully agree. And as I said, while we are presenting and talking about the broker and the OPC UA here, OPC UA really needs to live on a scalable infrastructure. Otherwise, it will not be able to reach the promise or that the customer or the wish that the customer has, that this is simply, I go with my mobile phone and I see everything that is happening on my factory, right? Or my headquarter can actually better optimize the supply chain because they have access to all the parts the spare parts that are distributed across multiple sectors and so on.
I agree.
We need the scalability of the infrastructure to be able to fulfill those use cases for our users.
Yeah.
Okay, so very quick on the features, the key features. So we are a native Kubernetes workload. It sounds simple. It was not that simple to get there, because think about, we are connecting to an OPC UA server that in the best case lives on a virtual machines. Most times it's really deployed directly on the hardware. So in order for us to be able to have a broker that oversees the the reschedule and so on of Kubernetes, we really have to do some twist and we really optimize for the customer to have a continuous stream and a continuous operation regardless of where the OPC UA server lives. So that's what has been part of our work on really taking the broker to the next level. And NORBAN for us, it's IoT MQ, and I think you have a session to go more into this. But basically, we are taking OPC UA data and publishing to our MQTT broker. For those viewers that are more experts, we are not changing the payload, right? So the payload still remains OPC UA. Once data is being available in the cloud, then it can be treated as OPC UA data. We just use a fast mechanism in order to bring data from the OPC UA server into the cloud.
Mm-hmm.
Then we are using ACRI to do asset detection. And we are at the beginning of the journey here. We want to enrich a more flexible way. That means assuming in the OT space a new asset is being deployed, it could be that there is a spare part, a retrofit, an upgrade to a particular component, and this can be auto-detected by the OPC UA server. And from there, we want as well to detect this and to show to the cloud user, to the developer, that things have changed. That could mean as well that the tags are going to come in a different format because we have a new spare part there that communicates slightly different. Or it could as well be that changes have been done to the whole machine itself that now can produce at a different speed or can have different functionality. So those are important, that we detect what is being changed there and we bring it into the cloud. Yeah. And for the customers that have the network isolations and they are following the ISO 95 or other standards, we are using MQTT bridge. So basically, we can bridge from one network to another one, only to one tunnel. So data is just being pushed out, and we never push back down, so that we can follow their network isolations and the separations of the network there. Okay. Let me quickly walk you through what does the broker do, actually, how does the architecture looks like. So we talk about the OPC UA servers. Behind the servers are assets. And then as part of the IoT operations, we have the OPC UA broker with 3 components: a discovery handler, an OPC UA connector, and an operator. And we have a couple of additional components that we are connecting to. So first of all, we need an ACRI agent. The ACRI agent will help us trigger changes or updates that are coming from the cloud. Then we are actively using the Kubernetes API server, the Kubernetes schedule, and the etcd. So a typical flow will be like this. I have my asset endpoint, this server URL that I showed a couple of minutes ago. With this, I create in our digital experience portal, I create an asset endpoint profile. This asset endpoint profile is being triggered or is being pulled down to the edge, where an ACRI agent will get the information that I have a new asset. As part of this, we'll identify this is an OPC UA asset, then we'll trigger the OPC UA discovery handle. The discovery handle picks up the configuration that I provided, so this URL as well as the security profile and additional information that I provided about my OPC UA server, and tries to connect to the OPC UA server. Once this is connected, it reports back that this was successful, and then the OPC UA connector, it's being activated and triggered. In addition to this, the operator is going to actively monitor for changes to the Kubernetes CRTs. And if there are new changes, that means a new asset has been deployed, a new asset it's available, we'll simply take the asset definition and send this information to the connector, who will then try to extract the relevant data. If I make no changes to the asset as it was discovered, that means I take all the telemetries, all the tags, all the node IDs, then there will be no difference. But we have seen customers and use cases where they basically want a subset of the information from a particular asset. And this is why we still need to have the operator and the connector. The operator says there is a new asset, and the connector says, okay, but the asset has a different configuration than the one it was discovered, and the end user is only interested in those telemetries. As mentioned, northbound, it's all MQTT, so that means the OPC UA telemetries with the OPC UA payload is being sent to MQ, or is being published on an MQ topic, and from there up into event grid.
Yeah. And I know that you also have an awesome demo to show me there, Simona. One again, just one commentary here. You mentioned before that as we're talking to users and customers, sometimes we hear this notion of I'll figure that out, right? And when you look at this type of architecture diagram, when you look at the scalability of how we are doing things, and again, you talked about this in the previous slide, in the notion of native Kubernetes. Like figuring this out to me also means that you need to figure out really how this is deployed in a scalable fashion. And looking at this architecture diagram, that's exactly what it means, right? So when people are telling us, "I'll figure that out," that's why I would say, challenge accepted. Because this is an all different level of scalability based architecture. So again, just commentary and reacting to what I'm seeing here on the screen.
Yeah, I mean, one thing to mention as well, many of the customers that are trying to build it on their own, they will either bring a database at the edge or bring another sort of JSON format and so on. Think about this as the single point of failure, because once this becomes unavailable, then basically the broker will not know where to put the telemetries or for which asset and so on. And that's one of the reasons why we really leverage the infrastructure that we have. I will say to the best we can, but I'm working on this, so I have to be a little bit more engaged or more excited about this. But we are really leveraging it to the best in order to maximize the resources.
So show me the demo, Simona. Show me. I know that you have a very comprehensive demo for me and a fun one. I always like to look at terminal screens, especially when they are in this color scheme. So
we make it color.
Show me how to think about this.
Right. So I have here IoT Operation deployed with the code space, following the instructions from learn.microsoft.com. I think it's a relatively straightforward path there. And first, I want to show you all the containers, so all the services that we have available, and just to link back to the architecture. So you see here that I have the discovery handle. This, at the moment, the discovery handle, it runs on demand. So that means I trigger the discovery and I finalize the discovery. We are working on making it this recurrent. That means it will run every second or every 5 seconds in order to bring all the differences. And then I have the connector, and I have as well the supervisor that is helping me monitoring again all the CRTs and looking at publishing data into the right MQTT topic structure. So those are the services that are running. And again, this is a really deep dive, right? So those services will be available for the user to interact with. And here is where things become interesting. So in the this is an MQTT Explorer, right? In the MQTT Explorer, I see already my topic structures. I see my assets, and I played around for this demo with a couple of them. Let's take again the boiler. You can see as well here all the data points that are available, the events as they are defined. And you can see as well here the schema. Not ideal because my schema is still empty, but one of the things we are going to look at enriching and bringing more schemas and more things available for the users. And then under the data, the The same assets are showing me all the data, all the telemetries. I'm running on a simulator, so there is an update every second on this. But you can see, these are the typical OPC UA assets, and data is just being published. Those assets at the moment are being created in our digital experience or IoT operations. You can see the same assets being available here. I have as well a failed deployed asset. So if I'm not defining the tags, if I'm just creating here like an empty, where I go to tags, I have no tags, this fails as well. So we are doing as well validations if the tags are available and how those are going to operate. And I can easily, in my cluster, I can just create an asset by providing the asset name and the asset endpoint, which it's again the URL. In the case of the OPC UA, it's exactly the URL that I showed you at the beginning. That's one thing that you definitely need to be able to have at hand in order to connect to connect your asset.
Yeah. I love how we are, like, all the dots are connected. Even if if you pay attention to this, looking at Visual Studio Code, as you see the structure, right? You talked about the schema, you talked about how things look like. I think that looking at this in that environment, and even though it looks like the metrics, which is kind of cool, but looking at this and connecting, for me at least, to have that mental connection between the theory, right, and part of that is the architecture diagram, and also kind of see how the data is flowing from, I think that you had like the boiler there. That's really where that low level conversation happened, right? This is where the data is coming from. And when we're talking, again, we talked about this notion of data. This is where it's coming from. And it's kind of cool to see that low level view of the asset and the pipeline. So
yeah. So just a couple more things, because as part of IO, we introduced the concept of an asset. And this helps us to structure the tags that we have available and the data engine that we have available as part of the OPC UA. And there are a couple of things. So we have an asset endpoint profile. You see, I'm already mimicking the OPC UA model. That means the URL, the target address here, this server URL, as well as the security profiles are now configuration file as part of my asset definitions, as part of my asset endpoint profile. So I can actually have config files. I don't need to always go over my OT and ask him. I can actually structure my data and I can deploy it as part of the configuration of my asset on a particular cluster. And then we have the asset type, which is basically defining the schema, or is going to the area of allowing me to import an OPC UA schema. Or if I'm more advanced, and we know a couple of our viewers are in that situation, define my own schema. So if I don't go directly with the OPC UA schema, but I want to have a more complex schema that goes even between protocols, or it's really advanced for my AI models, I can definitely come with that schema to the asset type and post this. The asset type, it's helping us as well to know which parameters are writable. There are functional safety parameters that we know we should never touch, or at least OT will never allow us to touch. And that's there because we really need to take care of the safety. But there are additional parameters that can be adjusted, and most of the time are adjusted in the daily operations, and those will be flagged as part of the schemas, and we will know that I can actually accept the request coming from an AI model to change this parameter, versus I'm not allowed to accept the request because this is a functional safety request and I really should never influence that without a particular approval. I will say we should never influence that.
Right.
And when we bring together, so I have the connectivity to the asset, I have the definition or the schema of the asset, and then I have the telemetries that are coming and that I selected for the asset. This is basically what we now call an asset. And this is the configuration of this asset. We show it in the portal, and the asset itself lives in our device registry. And what I will say, and for me gets really excited, is how do I actually work with those assets? And I have two parts. One, my assets are now resources in Azure. How
Right.
amazing is this? I had my machine, and we started with the industrial machine, started with a production line or a boiler or a packaging machine. And now this machine, with all the information that I have available, it's in Azure portal, and it's available as part of my resource definition. And from there, my IT groups, my data scientists can interpret and can manipulate the best they can. And I think this is part of this transformation and the support for the digitalization that we are providing.
100%.
And the other part is I have available for my OT colleagues or for the IT OT conversion as well, the portal where they can go in and simulate. Here I took some print screens from our partners as well. So it's not only direct connection to OPC UA, it's as well available in multiple partner solutions that we can directly use today as part of the IoT operation and enrich the availability of the data via Azure.
Awesome. This is so good, really, Simona. I think that, as we are wrapping this very extensive and educational conversation between you and I, usually, when we do this type of episodes are, relatively shorter, but here, because it's such a fundamental topic, really, when we talk about, as part of this Jumpstart Lightning video series, as we talk about all the components and the moving parts, right? At the end of the day, none of this would have mattered without making sure that we have a solution, a legit solution when it comes to how do we bring the data in a secured fashion, right? All the way from those assets into, what you just showed in the, in the portal, to the point that you actually have, and obviously not just that, but to the point that you have an asset as an Azure resource. Like, this is an ARM object that we're talking about. And I mentioned this before, that this is really kind of the premise of what Arc was all about. We started with Arc-enabled servers, but now we got to a point that you literally have a boiler that has an Azure resource, which is, like, to me, that's really mind-blowing. So, super interesting to see. Simona, thank you so much for schooling me. You weren't kidding when you asked me if I'm ready. So thank you for that. I appreciate that a lot. And for our Jumpstart viewers, thank you so much for joining us. Make sure to watch the other episodes in this series. Make sure to like, subscribe, and appreciate the support. We'll see you next time. Thank you, everyone.